this is really appropriate for kind of chalk fly-throughs or anything where a scene is just not moving at all. This is a very simple animation that we created for in a few days, where we kind of had a static scene, nothing was moving, and we were simply flying through the space in a kind of nice chalk way, and then some of the static images were kind of popping up to explain the space and connect the images together. It was really just an image set which they wanted to kind of try and communicate where these images were sitting within the building. So locating each of the images, and the kind of fly-through was a vessel to do that. So these are really simple scenes to set up, chalk fly-through, and often we don't actually render every frame for these things. We render every other frame, and we use frame blending to kind of cheat. So when we're in kind of tight deadlines, we can only render half of what we need. But setting up these kind of scenes are very easy. And we'll try and show that again. And then again, even on the creative side of things, with a film like Megalomania, if we kind of skip through to some of this, a lot of this was apart from certain elements, a lot of this was kind of just rendered in fly-through, and with very simple scene setups, and render times were very low. Some elements were moving objects later on in the film, but most of the film was very static, moving through simple scenes with nothing moving. So in both accounts, we need to set up our scene. So basically, what we need to do here is we want to generate our light cache and a radiance map. Now, there are different ways that people are showing you how to do this on the internet, all of which are slightly different, whereas the method we use is to bake it in one pass. Certain techniques use a kind of light cache technique first, and you do it separately. However, there's no real need to do that. You don't really need to kind of set up your light cache, and render it on fly-through as a separate pass. You can do it all in one. So traditionally, you would set up your system like this. You would have light cache set. You would have fly-through set in the mode, and that's the same as setting use camera path. So you don't need to have both settings selected in this way. And then ideally, you want your scale of your light cache to be on world. And when you do this, you really need to up the subdivision size of your samples here to something more like 2,500. And what this is essentially is world setting will calculate the kind of 3D scene, and the whole scene is one light cache file, whereas screen will just do what you see within the screen. Now, this isn't advisable to use when you've got a huge scene, where there's lots of different objects and a large scene around your camera. But in this scene, for example, it's what we see in our camera is more or less what we see in what we have in our model. So if this was a small part of a much, much larger model, then we wouldn't really want to use world, because we're not going to get enough subdivision around our space to kind of generate a good light cache. So, but on this scene, it's appropriate to use world. All interior scenes, you should be using world. However, on exterior scenes, large exterior scenes, screen can be fine. So on screen, light cache of 1,000 is normally good enough for animations. And on world, a light cache of 2,500 is normally quite appropriate. Again, you want to check the number of the cores in your machines or your render farm, and just make sure that you're generating the passes, the number of passes within your light cache reflects that, because otherwise you've got power in your computer that you're not using. If you use the default 8, then you've actually got 12 cores within your machine. Once we've generated that light cache map, we'll render that out, and this is different to the previous method, because we can send this to the farm to all of our nodes. So it's not dependent on adding detail to a single map. Each of these maps are independent from each other, so they can be made on they can be generated on the entire farm that we've got to speed the process up. So if we have a look at these files, for example, we have our pre-pass file already calculated. We have our light cache. We have our pre-pass dummy file that is generated when we press save on those maps, and then we have the rendering of all of the files here. So you see minus, it displays it in a funny way, but V-Ray reads it correctly. So this is like 00, 001, and then it's got minus 001, 002, minus 002. It doesn't matter what order that's displayed in, that's just a naming thing for Windows, but V-Ray will read this properly. It will read it as -2, -1, 0, 1, 2, 3, 4, 5, etc. Look at the JPEGs that we're going to use. I'm not going to go through how we made the HDRI, but I'm going to kind of introduce you to a few bits of kit that we used to capture them, and just understanding what's the best tools really. So let's just quickly find our files here. So like we kind of briefly explained, this is our HDRI, and it's made up of 7 different exposures at 45-degree angles, taken on a kind of fixed tripod, which you can kind of see just here. What you can also kind of see here is our Nodal Ninja, which is our kind of device that we're using to rotate our camera on a fixed angle brackets. So we're rotating that every 45 degrees, and we're taking 7 different exposures. And we're not doing that manually, we're doing that using a promote control. Is a kind of like device which connects our camera, connects to our camera, and we can kind of really easily do time lapses and exposure bracket, multi-exposure photos and things like that. And then we're doing all of that with a 5D, with a non-crop sensor. Again, if you did this on a cheaper camera or even a 7D, you wouldn't get a completely spherical image, you'd get a cropped image basically, which is important when rebuilding the kind of 360 degree thing. But you can see from our HDRI that we're getting a great amount of lighting data. So you can bring it right back, and we can see that the sky is our light source, and it's giving us the kind of detail that we need for our lighting. And because we're kind of always within the streets, we're not going above it. We can just use this HDRI. We don't need to use any of the light whatsoever. You can see in the file that there was a directional light, and we did play with that for a little while, trying to recreate the lighting as accurately as possible. But we found that once we actually played around with the V-Ray light, with the kind of settings of that HDRI, we could get it roughly working. What we sometimes do is kind of activate V-Ray RT with nothing in the model, and just get our dome light source in the right place. And I actually did a kind of test for NVIDIA's new Maximus system last year, and testing specifically RT in production, and found it actually very useful for lighting setups and material setups for scenes. And I wrote a big case study on the NVIDIA website, which you can kind of hear more details on that if you're interested in kind of learning a bit more about RT and its relevance within ArcViz production. Let's just look at this. What we'll do is we'll look at our RGB. So we'll put our RGB over here. So that's our raw render, that's our RGB. Now, more often than not, you don't actually use this guy in Nuke, which is quite interesting. You kind of rebuild him using the other passes. And there's some passes that are that you render out for rebuilding, and there's some passes you render out just for effect or color grading or masks. So let's just go in and isolate our masks. So we have our alpha, and with this file we haven't got our sky separated out. We're rendering that out now, but I'll show you the differences between those two things in two different files. Let's just move our kind of passes we'll use for editing there. So basically, there's a few passes you need to rebuild your RGB. You need global illumination, so we'll put him over there. You need your V-ray reflection, your V-ray refraction, self-illumination if you've got self-illuminated objects, so it's just being aware of what you've got in your scene, specular, lighting, and background if you have a separate background in your scene that isn't part of your lighting setup. Okay, so at the moment, if we go back into our kind of viewer mode, at the moment these are very separate passes. You know, we can see our global illumination separately, our reflection, refraction, our self-illumination, we've got our dome visible, so we have that rendered in, as well as our kind of little light here. We've got our specular, but we don't have any specularity. So in this particular scene, it wouldn't actually be a problem if we didn't include this, but it's good practice to include the ones that you need anyway. And then our V-Ray lighting, right? So the way that we merge these together is using the merge node. So yeah, Nuke is pretty logical. And then if you double click this node, you won't be able to see anything because you're in your, you're just in your node graph here. But if you double click him, you'll get options within the properties. And that's where you can kind of change the parameters of what this object's doing. Likewise, if you double click on any of your nodes, it will kind of bring up options for that, where it's saved, the frame range, you can alter that, and all sorts of other options that you have here. So if we could double click on our merge node again, if we had this on the default 10, what would happen is this would quickly fill up, and it would get a bit confusing, and we'd have to kind of scroll down and all sorts of things. So I'll keep this on 1, just for organization's sake, and just double click on the node that I want to see the options for. So the default merge setting is merge over. What you want to do is change that to merge plus. And these are often called your plus files, or your plus passes. That's what it's often referred to in visual effects. So the way that you kind of use Nuke is that everything works with the kind of B channel pointing up and the A channel pointing us to the side. But so this is basically how we set up our scenes. We have all of our clones, which we can then use. So we'll rebuild our RGB back here. It's called. We won't worry about the naming. If we had more time, and we would change all of these to the name what we want. We know this is the RGB color, so we can plonk him on the side here. We know this is the background. What I tend to do also is just make sure that I'm using the right ones. This is our V-Ray lighting, specular, self-illumination, our refraction, and our reflection. So we had these in slightly different orders before, but that doesn't really matter, we haven't changed much. And again, we can just easily deactivate a whole bunch of stuff there. If you press X on a node like this, it will deactivate the whole thing, which is sometimes very useful. So also, when you've highlighted all of your elements, you can see exactly where everything's linking to. That becomes really good because when you want to bring in a new set of new renders, for example, you can kind of bring in your new set. You know, let's just, for the sake of argument, say that this is your new set that you brought in. You've updated things. You can just select everything in your scene, and then very quickly just update your scene with the latest assets. What we tend to do, which I'll explain more later on, especially for our kind of ArcViz image workflow, is that when we're in the development of a project, we kind of have a working folder, a current folder, and then we save all of our latest renders into that, and we overwrite. But then we copy that current folder and we date it when we do that. So we've always got a record of our kind of what we've done. But then we can have a current folder which is always linked in our Nuke comp, and then which is automatically updating every time we re-render. And then we have a comp which is automatically updating with all of our passes and things like that. And we'll go through that example slightly later on. So this is kind of our basic kind of setup for rebuilding our RGB. Now, I want to talk about how we use the passes and masks and the shuffling out the different channels. So we've got our RGB export here. let's just work with that for now. Or actually, let's update where we were at before, because we changed our background slightly, which we were slightly more happy with. So let's export where we're at there. Again, render him out. So this guy, we do the same thing with this guy. We would put him with our read nodes. We might want to organize this and name things slightly differently in different background nodes. We've got our export here, got our postage stamp, and then we are, if that's going to update, hang on 1 second. We're creating quite a lot of motion blur at this point. And although we did bake in some motion blur, we kind of try and do a half and half to give ourselves a little bit of flexibility. On some shots, we kind of render, when we have to bake in the motion blur on shots like this, we want to kind of give ourselves enough of a head start that it's kind of aiding our real smart motion blur, but then we don't want to do it too much, so we can't take some of that back or add some of that in post, basically. And you can kind of mess around with, we've kind of done lots of different tests with the kind of velocity pass that you can export within V-Ray, and we've had limited success, to be honest, with that. There's lots of ways you can do that within Nuke. You can even use a kind of source here for you can plug in the velocity pass here. So the real smart motion blur does support the velocity pass, but again, we find if for this particular shot we found it much better to kind of bake in part and then just add our kind of pixel motion here. But I'm just going to turn this down a little bit. It looks a little bit too extreme. Again, what you want to do is you want to match this to your footage. So I think at this stage we definitely want to bring in our footage, especially if we want to start kind of grading this in. So we'll bring in our simple JPEG sequence. We'll have a look at what that looks like here. So all we've done here is given it a slight, no, we haven't actually graded this. We'll just put these in place for grading. So we kind of leave these grade, color correct, and color lookup nodes there. So they're ready for grading in the kind of standard setup we have. So if we now click our merge over node, which is what we have. So what we've got here is that we've kind of piped in our feed through our depth of field on our motion blur, and then we're kind of piping it into our main tree here. The reason why we've kind of extended this out to the side is because when our comps get large, and we want to be able to turn off the motion blur and turn off the depth of field all in one, when these are all lined up, what you can quite simply do is select them all on the side and press D, and then you've deactivated all your kind of like heavy layers, which are going to slow down your viewport. So that's just why we have this going to the side here. We could just have this pumping down here and then feeding back in. It's just graphically we have it on the side so that we can turn it off very easily. We're going to ignore this light wrap feature for a second. We're going to talk about that more on another scene. And then what this line is doing, it's kind of going into our merge over node, right? Ignoring everything else apart from our merge over node for now. And this is saying that this layer is at the bottom, our footage is at the bottom, and our render layer is kind of merged on top of that. So anything that's above anything else is like a layer system going down. So let's have a look at that. The matte shadow is something we're going to talk about on the next shot, because what we've done here is that we've baked in our alpha, right? So our alpha, if you remember when we were talking about the matte shadow material, our alpha is baked in. So in that material for this context, we've unchecked the effect alpha channel. So that we've checked rather the effect alpha channel, so that our contact shadows and our kind of light that this object is creating is actually affecting directly our alpha, not just the matte shadow material. So in this method, it's good and bad. It's good because we can kind of bake in our alpha, and the contact shadows will work, work fine. If we take off our render completely, if we unplug this, so let's just put a little dot here so I can go back. If we unplug our render, you can see that there's no shadow there. If we plug it back in, the shadow's there, and we can kind of play around with the alpha and blur this slightly to get this better. But that was probably also if we created a slightly more accurate model, and then we get slightly better shadows. But again, with the motion blur activated, that doesn't matter too much, because as soon as we add motion blur to this, you're going to see that kind of smooth out anyway. So we weren't too bothered about that. But that's essentially, our shadows are baked in to our render pass here, right? So we'll talk about how we use this, how we use the matte shadow material on the next shot. In this shot, we kind of baked it in, and again, at this point we were trying out different workflows. So we were kind of like on each shot. This was our first project learning Nuke. This is why we're kind of showing a few different shots where we kind of figured out a few different things, basically. So it's good to kind of go through, and you can see already how from this initial comp, which the base principles are all there. You know, all these different elements are there. It's just that we got used to organizing things in a slightly more graphical way, which then more people can kind of come into and understand, basically. So that we develop this kind of template so that people can kind of come in directly and know what's going on, just labeling everything, basically. So we'll talk about the matte shadow in the next scene, and we'll leave the ambient occlusion because we haven't got it, we didn't render one out for this one, or we're not going to use it. So essentially, just to kind of simplify this composition, let's just bring this guy. Let's delete these two because we don't actually need them to simplify it. And again, this looks a little bit complicated, but this is developed because we want to essentially create our roto masks. So we can talk about that a little bit. So our roto masks are essentially rotoscoping nodes. So if we click on one of these, we can see that we've got a line here, which is kind of surrounding our main character. And we've got one of these for lots of different elements, like the gaps in there. We've got one for the bike. And again, this roto node was actually created by a junior person that we kind of employed from Escape Studios in London, and basically did this completely wrong. So it's good to kind of show what what's wrong about this. Well, you know, it sticks fine. It's kind of a clean roto. So what's wrong about this method of kind of rotoscoping? You know, we've got all these different elements, but it's not an efficient workflow for rotoscoping. So if we click on our Daniel character here, the way you should rotoscope is to create simplest forms as possible. So we've already got some quite natural, simple forms in here. But what we want to do is we want to separate out the head, we want to separate out the ears, we want to separate out the arms, we want to separate out the torso into separate roto nodes. And let's try and explain this on the model here, on this kind of scene here. And then what we're doing, if we double click this, is that in our mask, it's RGBA alpha. So it's going to kind of read the alpha through our kind of pipe here, and then we're multiplying that on as we would normally. And we don't have to multiply. We could grade. So if we put a grade node in here, and we did the same thing, we piped in the mask to that stencil. Let's just disable this for now. We can do the same thing. We can grade our shadow as we want. And that means we can change the color. We can try and match this guy. So we want to make this more blue. Which is not making it more blue. It is if you change the grade here. So if we click on, we can change the color of any of these wheels. So we can kind of create whatever we feel is close. It's not that successful, this one. If we press Alt and then click on the little number next to this, it will kind of reset the it'll reset our whatever we've adjusted back to default settings. So it's quite useful to kind of get used to that. So this gives us a huge amount, much more control of kind of getting our shadows looking good than if we then bake that in, because it'd be really difficult to kind of grade that shadow to be a specific color if we baked it in. And the only reason why we've got this stencil node here, which is kind of complicating visually our setup, is because the stencil node is essentially taking this mask, but it's also combining it with our main masks here. So that means we can, this roto pipe system that we developed can kind of cut our main render, but it can also kind of cut into our any other elements we add. And this is kind of a little bit more complicated a setup, and it really just needs a slightly more of an understanding of Nuke to kind of understand the different parameters of the merge node, basically. Because the stencil is it's literally stenciling these two together. So if we simplify this for the sake of this tutorial, because if we don't want to cut out our woman and our van and our car, the reason why we've done that, obviously, is because in our comp we have lots of things that pass in front of this scene, like this car, right? So if we didn't use this stencil node and we just masked straight into our shuffle node, then we're not masking the shadow. You know, it's going to be on top. The reason why we've put that there is because we can not only mask this grade or tell this grade to use from our matte shadow material, we're saying also take into account all these other roto nodes we've made. This is a kind of raw render from a recent project that we've done, and this is kind of like a mid-stage, I guess, in the process. And how we've started using Nuke within projects, a standard kind of project would be kind of like 5 to 12 images for an architect, and in this particular case, leading onto an animation or a film. And for these kind of things, especially working with you know, certain architects, it's going to be really tricky to keep feeding the images to the architects and the developers with good information, updates all the time. Sometimes you kind of built in fixed kind of like issues to the architects, but sometimes it's much more of a kind of process, especially with a project like this where the design wasn't necessarily fully realized before issuing the kind of information to us. So it was a bit of a designing process and a bit of a marketing. It was somewhere between marketing, images, and a designing process. They were used for marketing purposes, but we weren't issued with kind of final information. So there was lots of changes to this project, right? Lots of changes, lots of issues of renders. And what we've started doing, and we're going to use for all of our workflows now, is rendering out 2K images of our scenes. And that Nuke can work with 2K very easily. It's going to struggle to go to 6K unless you've got a really fast network and a really fast graphics card. But what we're using it for isn't really for final production. It's for all the kind of niggly stages in between. And so basically, if we have our read nodes here, what we'll do is we'll have all of these read nodes stored in a current folder for the render of this project. So what we'll do is we'll render out the image. We'll save this within a dated folder, or the current folder rather. And then what we've started to do is set up this as almost like a batch command, but using Max and Nuke, where we have and we've kind of gone to like extreme referencing, where we have all of the model files referenced into a cam lighting file, and in that cam lighting file you've just got your lighting and your cameras as you would normally, but then that file is then referenced into a render send file, right? So the render send file has got nothing in it apart from your apart from an area to send your render, and then what that means is you can send that to Backburner or wherever, whatever system you're using. And then whenever you update the camera, the lighting, any of the models, you can just press restart on that restart on that job in Backburner, and it's going to update everything for you, and it's going to render everything out in the same current folder, and all these nodes are going to update automatically. So what that does is gives us this mega fast workflow of essentially rendering out a set of images, setting up a comp like this. Now we've got the comp set up, we don't have to do that again. And then basically All the models are worked on by several different artists throughout the day. The lighting is slightly changed, and then essentially all we have to do is select our folder within Backburner, we press restart, and it's going to essentially take all of that new data, render it again, update these files, and then everything we do here, every adjustment we make is automatically updated. So that gives us a huge speed advantage when it comes to changes, where we overnight or over lunchtime will have an updated set of renders that we can simply press export, and that is rendering out a JPEG which is linked to an InDesign document, so that basically overnight we can kind of like press restart on all of our jobs, right? And then it automatically updates everything, and we automatically have an updated InDesign document which we have to PDF out and we send to the architects. It's completely streamlined our workflow for image sets.